Welcome back. In this video, we're going to look at the excess reactant. We've talked about it from a conceptual standpoint a couple of times now, but for some reason, when push comes to shove and we start doing math problems with excess reactant, this is where students have the most trouble. So I wanted to work through a few examples for you to refer to. I always think that students overthink this concept, and what you usually try to do as students is to memorize a series of steps to help you solve the problem, and that's okay, but I think that when you lose focus or you forget about what you were trying to accomplish, that's what makes things hard. So as we start this video, let's go through the idea conceptually of excess again. What does it mean when I ask you for excess? Well, in just simple words, excess means left over. Like when you eat dinner or supper every night, wherever you and your parents call it, you have leftovers if you don't eat everything. Excess means extra. You have too much. Or in terms of chemistry, it simply means you have something that's unused, unreacted. Logically, what do you need to know before you find leftovers? If I make 12 hamburgers, what do you need to know to figure out what the leftovers are? Well, you have to know what's used. You can't figure out what's extra until you know what you need or what you consume. When we do the math, where do we start? As I mentioned before in previous videos, we always start with the limiting, because the limiting always determines what you make and how much of the other reactants that you're going to need. Let's work an example together. A student reacts 50 grams of sodium with 100 grams of sulfur according to the following reaction. And you can see the reaction here. Sodium is found to be the limiting reactant. So we don't have to calculate limiting, we know kind of where to start. How much sulfur is excess? Before I start calculating the excess, let's figure out how much moles of each that we have. Sodium has a molar mass of 23. That doesn't look like a 23, so let's try it again. And S8 has a molar mass of 256.8. So take my word for it and allow me to do the mole conversions for you. I know you can all do mole conversions. So 50 grams of sodium comes out to be 2.174 moles. And then for the 100 grams of S8, 256.3894 moles. Now we're told sodium is limiting, so I don't have to divide by the coefficients or anything, but to do my excess calculation, I need to know the moles of my limiting, which is the sodium. So that's where we're going to start this. Start with the limiting, 2.174 moles of sodium. We've prepped, so let's go ahead and get into the stoich here. We're going to be looking at the ratio of the sulfur to the sodium. That is a 1 to 16 ratio. And that would give me 0.1359 moles of S8. Here's what's important. Needed. Okay, needed or used, whatever. That's how much we're going to have to make this reaction go. Now, if I take that, what we're going to do now is figure out how many grams that is. So we'll multiply it by the molar mass that we've already figured out before. And that is 34.9 grams of the S8 used. Sorry, that is used or needed. I'm using those words interchangeably for some reason, but they mean the same thing. So I need 1.1359 moles, but that also means I need 34.90 grams. But that is not the excess. So here we come, the critical step to figure out what's excess. I look back at the beginning of the problem. I have 100 grams. That's what I have. And I've calculated that I need 34.9 grams. So we subtract those, and the excess is going to be 65.1 grams. That is what's left over. Before we leave this problem behind, let's go back to the equation and let's kind of put this into some context with law of conservation of mass. Many of you might think that if I have 50 grams and 100 grams of each of my reactants, then I would here make 150 grams of products, because conservation of mass says we can't create or destroy. But that is not the case here. I am actually, sodium is limiting, so I'm actually going to use all of it. But we've calculated in this problem that we're only going to use not 65.1, we're going to use 34.9 grams of the sulfur. So when this is over, I actually have 65.1 grams of this remaining. And there's none of this. So how much of the sodium sulfide, Na2S, did I actually make? It's not going to be 150 grams. It's going to be 84.9 grams. And you can go check the theoretical yield, do the ratios, and see how close that would be if you just did a regular theoretical yield problem. I did it, and it's actually spot on even with the rounding. So that just goes to show you, when you have leftovers, we're still obeying the conservation of mass, but not all of your reactants get converted into products. All right, now I've provided you with another example problem, and it's not a baby problem here. There's actually quite a bit going on that I want you to practice. So Elmer here wants to perform a precipitation reaction. He's going to react 25 mils of a 0.25 molar silver nitrate solution with 40 mils of a 0.12 molar calcium chloride solution. Identify the excess and determine the moles that will remain, a little typo there, and then calculate the molarity of that solution. So what you've got to figure out is what the excess reactant is. In other words, you know how to calculate the limiting, so you need to do that, and then the other one will be excess. Before you get started, let's go ahead and address the fact that I gave you not grams, but I gave you molarity information, molarities and volumes. So for your prep work here, to get to moles, you've got to use the molarity equation. So hit pause, do your calculations to get to moles, figure out your limiting reactants, and then let's catch up from there. All right, if you did your calculations, we've gotten this far, divided by the coefficients, and now I'll look at my quotients here. I see the smallest number is this one, so my limiting reactant is going to be the silver nitrate. Now that you know that, see if you can work through the math now to figure out first how much of the other reactant is going to be needed, and then how much excess we would have in moles. So that's important. Here we're going to do it in moles, not grams. So hit pause, try that out, and let's catch up together there. All right, so we figured out that the silver nitrate is limiting, so therefore the calcium chloride was excess. But in our math here, we had to start with the limiting reactant, and then we used our ratio to figure out that we're going to need 0.003125 moles of the silver nitrate. Sorry, that's not right. That's calcium chloride. So that's what we need. We know from this number here how much of the calcium chloride that we had initially, and I'm subtracting what I've just calculated to be used, and then this is my moles of excess. So we finished the problem as far as finding the moles of excess. The last little part here is getting into molarity. Well, remember that molarity is moles per liter, so what we need to do is address the volume part. The new volume that we have here is going to be the original 65 mils. Nope, that's not right. The new volume is going to be the 40 mils plus the 25 mils that got mixed together, which is going to equal a new volume of 65 mils, which of course we're going to need to convert to liters, so that's 0.0650 liters. We got that, so the molarity here of this new solution of the excess reactant calcium chloride is moles, 0.017 moles of excess over the 0.0650 liters, and we get 0.026 molar. That's the molarity of the excess. So in this problem, we had a little bit different way to prep the problem and a little bit different way to polish it off into a final answer of molarity. But in the middle there, the stoichiometry step is always the same, and then that subtraction step is always going to need to be there as well. You can subtract grams like we did in example problem number 1, perfectly fine, but you can also subtract moles. It just really depends on what the problem's asking you and which one's easier for you to do. We got lots of practice on this, so ask if you have any questions and work hard on the practice that I've given you or will give you to do.